This video is on representing probabilities with diagrams. We're going to be looking at two-way tables, sample space, Venn diagrams and tree diagrams. And for each one, I've just got an example to show how they work and how we can work out probabilities from them. Let's start with two-way tables. People exiting a new ride at a theme park were asked whether they liked or disliked the ride. The results are shown in the two-way table alongside. Use this table to estimate the probability that a randomly selected person who went on the ride, liked the ride, is a child and disliked the ride, and is an adult or disliked the ride. With two-way tables, it's always a great idea to start off by making sure we have our totals for our columns and rows. So we have here 83 that liked the ride, 55 plus 28. Disliked the ride was 17 plus 30, which is 47. How many children are there? There were 72 children and 58 adults. And then overall total is 130. So that 130, you can always make sure that your rows and column totals are correct because they should add up to the same amount. Part A, probability that he liked the ride. So we'll go the probability of liked equals, we just looked at how many we have that liked the ride, which is 83, over our total, which is 130. Obviously, we can change this to a decimal if you wish, but it's not needed unless the question specifically asks you to. Part B is a child and disliked the ride. So child and disliked the ride would be the 17, because that's the only option in the table to have both of those. So that and is really important. We want the probability that they were a child and, so we use the intersection sign, they disliked the ride, which would be 17 out of the 130. Then part C is an adult or disliked the ride. Now, because it's an or, we need to look at everybody in this section. So we need to look at all adults, which is a 28 and 30. Then we need to look at all the dislikes, which also includes a 17. So it's all those three that I've circled. We need to add them together. And our probability of adult or, which is a union, disliked, is all those added together, which would be the 17 plus 28 plus 30 over our total, which equals 75 out of 130. And then this can be simplified down, 15 out of 26. Next, sample space. So we want to use a two-dimensional grid to illustrate the sample space for tossing a coin and rolling a die simultaneously, and then determine the probability of tossing a head, tossing a tail and rolling a 5, or tossing a tail or rolling a 5. So to draw a beautiful sample space, we need some axes, where we'll have, I'm going to put heads and tails, and then across the bottom, we have the numbers from 1 to 6 to represent the die. Now, we just put dots here for a sample space to show where it is a possible outcome. So we could have a head and a 1, a head and a 2, head and a 3. It is possible to have a head with any number, and also it's possible to have a tail with any number. And that's a sample space diagram. Now, if we're looking at our probabilities, so A, the probability of a head, which would be all of the dots on the bottom, which is 6 dots out of 12. There's 12 dots total in the sample space, which means our probability is a half. B, we want a tail and a 5, so intersection 5. So a tail and a 5 is just 1 dot. It's the only option we have of getting a tail and a 5. So that is 1 out of 12. Then C, we want the probability of a tail or, so the union, a 5. Now a tail or a 5 means we want all the tails and all the 5s. And from this, we just look at how many dots are in all those black circles, and there are 7. So it's 7 out of 12. Venn diagrams next. In a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both of these subjects. Put this information in a Venn diagram. So we need to draw our rectangle. Always make sure you have a rectangle with a Venn diagram, as that represents the sample space. Now we have physics and chemistry, so we need 2 circles. And now we can put the information. We have a class of 30, so we can just write 30 on the outside. I always like to, if possible, start in the middle. Now, we're told in the question that 15 study both of these subjects, which is where the two circles overlap. And then we also need to label them P and C for physics and chemistry. Now, we know that 19 study physics, so that in that whole circle of physics, it needs to be 19. We've already got 15 there, which means there'll be 4 left over that only study physics. 17 study chemistry. We already have 15 in the chemistry circle, which means 2 study only chemistry. Now, if we add those numbers up, we'll see we get 21, and our sample space is 30, which means there must be 9 students who do not study physics or chemistry. Part B, then we can start looking at probabilities. So the first one, probability that a student studies both subjects. So we want the probability of P and C, which is this bit in the middle that I've quickly shaded. So that's 15 out of our total 30, which is a half. 2, at least one of the subjects. So if it's at least one of the subjects, we want the probability of it being physics or chemistry. Now, physics or chemistry is all of the wonderful circle parts, including the intersection. If we add all that up, we get 21 out of 30, which is 7 out of 10. 3, physics but not chemistry. So we want physics but not chemistry, and we want chemistry complement. Remember, the little dash means not chemistry. So just physics and not chemistry will be this part of the physics circle here, not the bit that overlaps, because they also do chemistry and we don't want chemistry. Which means it will be 4 out of 30, which is 2 out of 15 simplified. Part 4, exactly one of the subject. Now there is a way to do this in notation, but I don't have enough space, so I'm just going to write exactly 1. Now exactly 1 is going to be the physics of this part and the chemistry this part. It's not going to include the intersection because they do both physics and chemistry, and we want people that are only doing one subject. And that was 6 out of 30, which equals 1 over 5. And then the last one, neither subject, so that's on the outside. So we want not physics and not chemistry, which is 9 out of 30, which simplifies down to 3 out of 10. So Venn diagrams are a really easy and good way to be able to see what probabilities and which numbers go where. So if it is a kind of a Venn diagram type of question, I would always recommend to draw it, because it does make things a lot clearer when we're looking at certain subjects or both subjects, etc. Lastly, tree diagrams. A bag contains 10 balls, 6 balls are black, 4 balls are white, 3 balls are drawn from the bag without replacement. Determine the probability that 1 black ball was drawn. So for here, we need to start drawing our tree diagram. We're going to have 3 sections because we could take in 3 balls out of the bag. So we'll start here, and we're going to have the black ball and the white ball. And this is the first time we do it. So when we first do it, we have 10 balls in the bag and 6 of them were black and 4 were white. Now we've got to do this again for the second ball. We could black out the first time, which means that on the second time we're doing this, we will have 1 black less, and there'll only be 9 left in the bag because we've already taken 1 out, and the question it does say without replacement. White, so there'll still be 4, because this one's coming off the black, which means we did take out 1 black, so there'll still be 4 whites in the bag. Now go to the bottom one, which is a white first, which means there'll still be 6 blacks out of the 9, and then there'll now only be 3 whites and 9 left in the bag. Then we do this again, so we have to do them off each of them again for our third ball, and we do the same process again. So this top one here, we've already had the black come out twice, which means there's 1 less, so we'll only have 4 out of 8 this time. There'll still be 4 whites in the bag though. The next one down, we have a black, then a white, which means there'll be 1 less of each than what we started with. So it'll be 5 out of 8 and 3 out of 8. The next one we had white, then black, so it'll be the same, 5 out of 8 and 3 out of 8. And the last one, we picked 2 whites out first, which means we'll still have 6 of the black in the bag and we'll now only have 2 whites. Always good when we have done a tree diagram is to make a note of all the outcomes. So this one was black, black, black. This one was black, black, white, black, white, black, black, white, white, and so on. Now we want the probability that one black ball is drawn. So we need to look at all these outcomes and see where we have one black. We have one black here, here, and here. So we need to look at these 3 pathways from the tree diagram and work out the probability of each of these. So to get this BWW, we had to do the B first, which was 6 out of 10. We times it by the next white, which was 4 out of 9. And then the next white was 3 out of 8 to get to here. So on the diagram we did the black first, then we had the white, and then white again. So I've just pathed it out in black on the diagram. Now when we're working across a tree diagram, we always multiply. And then we can need to do the same for the other 2 options of having one black. The next one down, it was white, black, white, so it'd be 4 out of 10 times 6 out of 9 times 3 out of 8. I'll just show the path. So we did white, then we went black, and then white. And then the last one was white, white, black, so 4 out of 10 times 3 out of 9 times 6 out of 8. And the path for that one was white, white, black. Work all of these out and we'll get 1 over 10 for the first one, 1 over 10, and they all end up actually equaling 1 over 10. So then to find out the final probability of having one black, we then add them. So when we're working down with our probabilities from a Venn diagram, we always add. So we're 1 over 10 plus 1 over 10 plus 1 over 10, which equals 3 out of 10. And that is the end of this video on probabilities with diagrams.